So here's some more from section 2.3, another uniform motion problem this time. Problem number 2 says two small planes start from the same point and fly in opposite directions. We know that the first plane flies 30 miles per hour slower than the second plane, and in 3 hours the planes are 1,170 miles per apart. So we want to find the rate of each plane. Uh-oh, here we go. Another distance, rate, time problem. Well, it's not a big deal. We know that we're going to be using our formula right here that says distance is equal to rate times time. Anytime you see the words rate or distance in the same sentence, your mind should automatically go to this distance equals rate times time business. So what do we do with that? Well, I always start with a picture. Again, just to give myself sort of an idea, we've got a little bit of a different flavor of a problem from the first one that we were talking about. In this case, both planes start from the same place, but they fly in opposite directions. Now, they're going at different rates, so they're not going to be necessarily flying the same distances. Right? So we've got distance 1 for one plane, we've got distance 2 for the other. Well, what do we know? Well, we know that both planes have been flying for the same amount of time, right? So we know that plane number 1, plane number 2 have both been traveling for 3 hours. So time t equals 3 hours for both. So this is our first thing that we know. We also know that the total distance of the two planes leaving from the same spot is equal to 1,170 miles. All right, so how can we use that? 1,700 miles, not ml, looks like milliliters almost. mi, there we go, it's a little better. Well, in this case, what we're going to be doing here looks like we're going to be saying we need to add our two distances, distance 1 plus distance 2 together. And we need some expression for our distances to get that. So this is a really good job for that table again. And I'll show you how I might set this up right here. We know that we've got two planes, so we'll call it plane 1, plane 2. Right? And we know that we will be taking our rate times our time to get our distance. Right? And we know that there's a total distance of 1,170 miles. Now, we need to be careful here with time. Time is the same for both planes. It's not a total time of 3 hours. One plane flies some part of that 3 hours. The other plane flies another part. They're both flying the same amount of time of 3 hours. So let's go ahead and put that in right now. We know that both of them will be flying 3 hours. How about our rates? Well, that's what we're being asked to find. Find the rate of each plane. So our job might be to say, well, all right, let's take one plane or the other. The first plane flies 30 miles an hour slower than the second plane. Well, maybe if we find the rate of the second plane, right, what would 30 miles an hour be slower than? Well, if we say 30 miles an hour slower, we mean in an additive sense that we're actually taking away 30 miles an hour. So if one flies 50, the other one flies 20. Maybe that's not the speeds, but we understand the idea right there. If x miles per hour is how fast plane 2 is going, then x minus 30 miles per hour is how fast plane 1 is going. Well, this is a perfectly good formula because now we can just simply multiply, take 3, the amount of time, hours, times x minus 30 miles per hour to get the distance that plane 1 flies, and 3 times x miles as the amount that plane 2 flies. And we know that added together, we're going to get our total, right? The word total is always interpreted as a sum. So we have the formula right here in our last row of 3 times x minus 30 plus 3 times x miles is equal to a total of 1,170 miles. All right, so what do we do with that? Well, let's go ahead and carry out the addition, subtraction, whatever we need to do to combine our terms. 3 times x minus 3 times 30, that's 90, plus 3x equals 1170. Then we take 3x plus 3x, add together our like terms to get 6x minus 90 equals 1170. Seems pretty good. Add 90. Oh, yeah, so add 90 to both sides. Let's add 90 to both sides, and let's see what happens right here. We've got 6x is equal to 1170 plus 90. We know that that's going to come out to be 1260. 1260. So now we divide both sides by 6 and do a little bit of long division off to the side. I know 6 goes into 1260 how many times? Well, let's see. 6 goes into 12 twice, giving me 12. Subtract that away. So just bring down 6. 6 goes into 6 once. Subtract that away. 6 goes into 0 0 times, so x must be 210. Now, that's a nice number and all, but we need to make sure we put that in context. What we asked the rate of each plane. So it looks like plane number 2, flying at x miles per hour, is going to be flying at 210 miles per hour. Plane number 1 is 30 miles an hour slower. So if we subtract that away, we're going to get our speed for plane number 1. Plane number 1 will be flying at 210 minus 30. That would be 180 miles per hour.